the SIO chip is quite complex, there's a lot of pins, and we have nothing. Here we go, here is the problem. No shorted pins, no shorted pins, no shorted pins. And here we go. We have a reaction. And right now here we have a short. Can lift this pin up, disconnecting the SIO, just a chip that quietly stopped working. Alright, GIGABYTE AORUS X570 Elite. Completely dead, no reaction whatsoever. Customer says it just stopped working. No story, no context, which honestly makes it more interesting. Now, if you have watched this channel before, you know how this goes. But if you are new, welcome and pay attention, because what we do here is not guesswork. Every board has a reason it stopped working, and we're going to find it. First thing, we'll look carefully before any tools, before any tests. The board itself usually hints all what happened, if you know what to look for. Then we go to the multimeter and check resistances on the ATX24 pin connector and the CPU 12 volts header. Those two checks alone will tell us whether it's safe to even attempt powering this thing up, or whether there is something nasty hiding inside. If the numbers are good, we apply power and see what happens. If not, we go deeper. Disassembly, microscope, component level, and I will tell you from experience with these boards, it's not always what you expect. Let's get started. Alright, multimeter out, resistance mode, black probe goes to ground, red probe goes to the pin we're testing. Simple concept, we're measuring how much resistance exists between each power line and ground. A healthy line will show some resistance, 0 or close to 0 means a short, and a short means something on that rail is damaged. That's what we're hunting for. Okay, starting at the ATX24 pin connector, this is the main power connector, and it fits almost everything on this board. We are checking the 12 volts line, and we have mega ohms. Then we check for 5 volts line, and we have around 2 kilo ohms, which is normal, and 3 volts. And 3 volts also has kilo ohms. Then we have a 5 volt standby power, 5 VSB. It's 18 kilo ohms. The minus 12 is usually 0. Okay, it's nothing here. It's good. And next, we will move to the CPU 8-pin connector. So this fits the processor power delivery directly, the VRM section, the inductors, the MOSFETs, everything that keeps the CPU alive under load. So on X570 boards, this area works extremely hard, and it's one of the first places things go wrong. So what about the 12 volts to CPU resistance? And we have 130 kilo ohms, so that's enough. Now, it's very important to check that there is no short between 12 volts and V core. So we will use one of the coils outputs over here and 12 volts pin here. And we have mega ohms here, which is good. Usually I check the last one as well, because this is the SOC line, usually. 5 mega ohms, and the first one, 4.2 mega ohms. So there's no short to 12 volts, and it means that the 12 volts will not go to the CPU. Also, I wanted to check within the ground, there's some open coils. So usually this is coils for the PCH power or for the memory slots. So let's check the resistance on them as well. Kilo ohms here, kilo ohms here, and kilo ohms also here. Here probably we have a 5 volts coil. Oh, sorry, 5 volts MOSFET. It's 196 ohms. This is normal. There's 2 more coils. One coil is basically, I guess, for the PCH. And no, it's 10 kilo ohms. It's too much. For the PCH, I expect something around 100 ohms, or maybe even less. Here we have also kilo ohms. Okay. Okay, perfect. So the resistances are normal, and we can try to power it on. Resistance is fine, nothing suspicious. Time to give it some power. Bench supply 12 volts to ATX adapter connected. Today we will use Ryzen 3 Pro 4350G. It's an AM4 CPU. And before installing a CPU, it is better to turn off the power on the motherboard. So we'll plug the CPU in. Now pressing the power supply button, and we have 186 milliamps of consumption. So pressing the power button, and we have nothing. So there is no reaction. So I think that we will follow to the microscope inspection and to see maybe we have any knocked off components or, I don't know, like blown MOSFETs, blown caps. Let's take a look. Okay, so the first area I would like to see is the SIO area. Try to clean it a bit. And I don't see anything critical in this area. So let's move on to PCH. So the most important here is to see the corners of the PCH silicon here. And the corners are perfect. Then what I would like to do is to measure chipset resistances on the small capacitors, which are on the chip. So we'll measure this. And we have 10 ohms, kilo ohms, 132 ohms, 130, it's 9 ohms, okay. 7 ohms. Oh, wow. This is, I guess, way low. Let's measure resistances on the coils. So those are the coils for PCH. We'll measure here. We have ohms here. 1 kilo ohms here. Here we go. Here is the problem. It's just 4 ohms. This is kilo ohms. Here is normal. So this... Let's check the schematics real quick. So before we go any further, I grabbed a donor X570 board to cross-check. Same measurements, same conditions. And the working board reads even lower than the dead one. So meaning this is completely normal for this platform. The X570 just sits low on this line. The chipset is fine and we're not going down that road today. So back to the drawing board. So let's move on within the inspection. And here we have memory coils, I guess. Okay, this is the most sensitive area on the boards. And so we need to be sure that the components here are not damaged and knocked off, because this is the place where the graphic card is mounted. This is audio codec. And this is our corner, which looks fine. No shorted pins, no shorted pins, no shorted pins, no shorted pins. I don't see any shorted pins on this side. This is an RTC area, so there's a battery here. This is a power controller chip, which is usually responsible for LEDs and some other things. There's 2 fuses for LEDs, which is good. Here the USB 3 fuse right here. Here is also the fuse for USB, and there's no fuse for TPM. This is our BIOS chip, and it's a 25U whatever. It's a 2025 U12873F. VR controller. And it looks normal without any visible damage. Here we go. We have several MOSFETs here. Okay, so those two lines are probably SOC lines. We have dear MOSFETs represented by two MOSFETs. This is a high side and low side MOSFETs. And the V core is made with the power stage chips. So this is our dear MOSFETs, which actually includes in itself a driver and high MOSFET, high side MOSFET, and low side MOSFET as well. And I guess so the drivers for the first two will be on the back side of the board. And yes, here we go. If we're already here, so let's check the under the PCH area. Now I don't see anything critical here. The CPU area looks fine. Nothing visible. Resistance checks didn't give us a straight answer, so now we go deeper. We're switching to voltage measurements. First stop, standby lines. They are live the moment you plug in power, before you even touch the power button. So if something is missing here, the board never even gets a chance to start. Resistances, the main power rails looks normal, but pressing the power button gives us absolutely nothing. So we should go to the SIO chip. But before this, we should check that we have 3 VSB and 5 VSB. So we'll power on the board, and I bet we have them. So there should be 3 volts here. This is a 3 VSB or 3 volts dual, and we have it 3.4 volts. And 5 volts we should have over here. All right, so 3 and 5 we have on board. Now let's move on to the SIO chip. Okay. So the SIO chip is quite complex. There's a lot of pins, but what we need to check, I open a board view just to see. Usually the main power supply rails, they goes alongside with the large caps. For example, so we should have ITAVC on this large cap from that side. And we have just 0.6 volts. Okay, I'm not sure if it's normal or not. I guess maybe no. We should have, I guess, 2 volts right here. Okay, so 0.8 volts. This is already something wrong, like there shouldn't be 0.8 volts here. Here we have a power button signal and trying to press on the power button. So I will plug in the power button. The power button is number 7. It's 1, 2, 3, 4, 5, 6, 7. And, okay, wait, no, 8, right? There's a 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. It's 1, 2, 3, 4, 5, 6, 7, 8. This pin here. We have 5 volts here, and I press the power button, and it goes to 0. So the power button works, and the signal from the power button goes to the SIO. And there is a signal PS out, is the pin number 5 here. It should go low after the power button pressed 1, 2, 3, 4 right here. It is high, so it's normal. It goes to the power supply. When I press the button, the power button, there's no reaction. We have also sleep S3 signal. This is the signal, it's a pin number 4 right here. And we have it, 3.3 volts. This is normal. When I'm pressing the power button, no reaction as well. Okay, so something is wrong. Let's check the battery voltage. The battery voltage is pin number 2 right here. Okay, and we don't have a battery voltage. This is a VBAT signal. Okay, this is weird. Like, what about the battery? Oh, okay. So the battery is empty. Let's replace the battery. Okay, so we replace the battery, and now we have 2.9 volts. There should be a new one. We have 2 volts here, healthy. So maybe I have another one. This one, let's check this one. Here as well, okay, 3 volts. Well, 3 is enough. Why it's 100 milliamps less than? This is interesting. So when it goes to ground. Okay, looks like something is draining the battery. Let's check right now the SIO pin. Do we have a voltage on the SIO pin or no? So remember, this is a pin number 2 right here, and we don't have. Okay, so what I would like to check right now is to measure the resistance. So I will remove the battery. And let's check the resistance. The pin number 2, the resistance to ground, just to know it's not shorted. And let's do this. Okay. Oh, wow. 2 ohms. This is almost completely shorted. Let me check the board view real quick. The only thing that can be shorted is, here we have a battery. The voltage from the battery goes to this resistor. This is a 1 kilo ohm resistor. And then goes here, it enters here, then goes from here to here. And this is the diode. This is a VBAT 54C. So it can go technically here and here. But if you see right here, we have 200 ohms. So it is not shorted, right? So then the short on this side. If it's short on this side, the only components that connected here you see the trace going down using a via. It's the SIO pin number 2 in this capacitor. So you see there is a trace going to this cap, and this is a short right here. So either this cap is shorted or SIO is shorted. We need to find out. I bet that that could be a failed SIO because we see the abnormal voltages on the pins of the SIO here. So I guess the short could be internally inside the SIO. But to be sure, what we can do, we can lift this pin up, disconnecting the SIO from the VBAT line, and then check if the short on the pin or the short on the VBAT line, and we will try to search for another culprit. Let's do it. Resistance here, and you see we have a short. And resistance here, and we don't have a short. So let's move it to the resistance mode and to the resistance mode on this line. And right now here we have a short. Yeah, just 1.9 ohms. This is basically a short, like here. That's a ground pin. Yeah. So this is the problem. So I guess that SIO is damaged and we need to try to replace it. Okay, the new SIO is soldered. Let's see if it made any difference. Okay, the bench supply is connected. We have memory, we have CPU, we have two power cables connected, we have our power button, and we have HDMI card. So let's try to power on the power supply. It's 177 milliamps. Pressing the power button, and here we go. We have a reaction and a normal current consumption. So I guess what we need is to open the power screen and to put some heatsink to the CPU. Okay, will we have a post? Okay, the current is changing. 2.5. And here we go. We have a picture. So, the problem was the SIO IT8688E, this Super I/O chip. What was interesting here that that battery was actually our first clue. The SIO was internally damaged and pulling the VBAT line down with it. Once we swapped the chip, everything came up normally. I'm really glad this one worked out. So that's it for this repair. GIGABYTE AORUS X570 Elite completely dead, no reaction to the power button, and it turned out to be a faulty Super I/O chip with no visible damage at all. And if you've been following the channel, so this is actually the second time we've seen an SIO fail this way, like no burn marks, no shorted signals, nothing obvious, just a chip that quietly stopped working. What made this one tricky was the low resistance on 1V SoC that looked like a cheap short, but comparing it against two working X570 boards showed it was completely normal for this platform. So, always worth checking your reference before going after the big components. I hope you found this useful. Thanks for watching, and I'll see you in the next one.